Hey guys, this is Mrs. Harbin, and this is Algebra 1, Section 2.4. Our verse for this chapter is Ephesians 6:10 through 18, which says, "Finally be strong in the Lord and in his mighty power. Put on the full armor of God so that you can take your stand against the devil's schemes." We're told repeatedly throughout the Bible that we have to have a firm foundation and we have to be fully prepared to handle a multitude of things, and math is no different. It follows that same structure. We've got to be prepared with the foundational pieces before we can solve challenging problems. So let's get to those foundational pieces. Our lesson objective for today is this. You, the student, will determine whether an equation is true or false. Identify and apply properties of equality when solving one-step equations. An equation, first of all, is a mathematical sentence stating that two expressions are equal. You've been dealing with equations for a long time, all the way back to elementary school, where you had this, 1 plus 1 equals 2. And you learned that that was a true equation, that 1 plus 1 does equal 2. And as you got older, you maybe got some more complicated equations, like 10 minus 5 equals 5. Each of these is called an expression, and the equal sign between the two of them tells us that they are equal, or equates them. That's where we get that word equation. There is a symmetric property of equality with equations. Whatever is on one side has to equal what's on the other side. So if A equals B, then B equals A. If 1 plus 1 is the same thing as 2, then 2 is the same thing as 1 plus 1. When we see this equal sign, we can also use the words is, or we can say is the same as. Sometimes students don't do so well with the word equals, and they would rather say is the same as. 1 plus 1 is the same as 2, or 2 is the same as 1 plus 1. You use whichever you like. You'll hear me here use all three in class. So numerical expressions can be true. So this equation right here is true. Negative 26 is the same as negative 26. Those are the same numbers. That is true. Or they can also be false. Okay, if I simplify this equation, I get 20 is the same thing as 11. And that's false. 20 is not the same thing as 11. So sometimes you'll be given an equation and asked to tell if it's true or false, and this is what it's asking. When you simplify it, do you have the same thing on both sides? Or if it's false, do you get two different numbers? A conditional equation is an equation whose truth depends on the value of the variable. Take a look at x plus 4 equals 7. What would x have to be in order for this to be true? Hopefully you said x equals 3. If x equals 3, it's true. But if x is any other value, like x equals 2, then it's false. So conditional equations are equations with variables, where the variable has to be a certain number for it to be true. Each number that makes an equation true is called a solution of the equation. So in our previous one of x plus 4 equals 7, we said that x, in order for it to be true, x had to equal 3. 3 was a solution to that equation. Sometimes complicated equations can have multiple solutions. Simple equations, like the one right up here, only has that one solution. But sometimes we can have multiple solutions. But a solution is something that makes the statement true. To solve an equation, you must find the values that make the equation true. We have to find the values of x that make the equation true. So how do we do that? Well, we have x minus 17 equals negative 35. We could sit here and count on our fingers or draw a number line or try to think logically, but there are some actual steps that we can follow to solve for x as well. What about this? Or this? Or this? Some of these you might be able to look at and figure out pretty quickly on your own, but we want to go ahead and follow a certain set of procedures so that when we get into complicated problems, we've got the foundational pieces. So before we get into that, let me remind you what an inverse operation is. An inverse operation is the operation that reverses or undoes a given operation. Equivalent equations have the same solutions. That's another definition that you need to know. Talking about inverse operations, I think we see this on another slide, but addition and subtraction are inverses. They undo each other. Multiplication and division are inverses. They undo each other. And exponents and roots are inverses. They undo each other. All we're going to be looking at right now are these four main operations. You'll learn about other operations and inverses as we move along into more advanced math problems. Equivalent equations, like I just said, have the same solutions. So two equations that are equal to the same thing are called equivalent equations. So example, 4 plus 3 is the same as 5 plus 2. Even though these are not the same numbers, they're both equal to 7. They are equivalent equations. Our addition property of equality says if A equals B and C is a real number, then A plus C equals B plus C. Let's do some numbers here. Let's make A equal to 4 and B equal to 3. So 4 and 3. And let's make C 2. Except for 4 isn't 3. What am I thinking? That made no sense. 4 and 4. 4 and 4. Goodness. If I add 2 to both sides, I now have 6 equals 6. That's still a true statement. You can also subtract the same number from both sides of an equation. So 4 minus 2 is the same as 4 minus 2. You can also multiply both sides by the same number. 4 times 2 equals 4 times 2. And you can divide. 4 divided by 2 is the same as 4 divided by 2. Whatever I do to one side, I need to do to the other. Remember that this is supposed to be symmetric. Equations are symmetric. In order to keep things symmetrical, I've got to do the same thing to one side. I've got to do it to the other side as well. So to solve an equation, what are the steps? We need to find what is happening to the variable, and then do the inverse operation on both sides. Solve x minus 12 equals 15. Well, let's look at just this side. And what's happening to that x? Well, it's having 12 taken away from it. It's having 12 subtracted from it. We need to do the inverse operation. We need to undo that minus 12. And the inverse of subtraction is addition. So we're going to add 12. And whatever we do to one side, we have to do to the other. Those 12s cancel out on one side, leaving us with x equals 27. To check our work, if we substitute 27 back in and evaluate, we get 27 minus 12 is 15, and that is a true statement. X plus 2/3 equals negative 7/12. Well, let's look at the side that has the variable. And what's being done to it? It has a positive 2/3 being added to it. Let's undo that by subtracting 2/3. Whatever we do to one side, we have to do to the other. And we end up with x equals negative 7/12 minus 2/3. 2/3 is the same as 8/12. And when we combine those, we get x equals negative 15 over 12, which can be simplified to x equals negative 5 over 4. If we were to plug that back in, we would be able to make a true statement. Negative 15/12 plus 8/12 is 7/12. That is true. What about 3x equals 99? What's being done to the x? Doesn't have anything added to it or subtracted from it. Instead, it's being multiplied by 3. The inverse of multiplication is, hopefully you said division. So we're going to divide it by 3. 3 divided by 3 is 1. So we're left with 1x, which is what we're trying to solve, the value of 1x. And 99 divided by 3 is 33. So 1x is the same as 33. So here are your steps. First, determine what operation is being performed on the variable in the equation. What's being done to the x, or the y, or whatever variable it is. Perform the inverse operation on both sides of the equation. Undo what's been done to your variable, and do it on both sides to keep your equation balanced. Then simplify both sides of the equation by combining like terms or simplifying any fractions. Check your answer by substituting it back into the original equation to make sure it is a true statement. Let's practice writing some expressions. The difference of a number and 10 is 37. How would we write that? The difference of means subtraction, a number, and 10. We're going to use n for number and 10, or x for number and 10. I like to use whatever I'm trying to find. If it's a number, I like to use n. Is means equals, and 37. There we go. X minus 10 equals 37. Now, how do we solve for x? How do we find out what 1x is equal to? Let's look at the side with the variable and see what's being done to it. It's having 10 subtracted from it. Let's use inverse operations. Add 10 to both sides here. And when we do that, we have 1x, this zeroes out, equals 47. If we plug that back into our original equation, we should find that that is a true statement. Sometimes you'll be given formulas and asked to solve for a letter, and there won't be any numbers. These are called literal equations. In the literal equation, you're going to do the same steps that we just suggested or just gave you beforehand, just without numbers, but the steps are the same. Let's see what that looks like. We're solving for a, so let's look at the side with the a. What's being done to the a? Hopefully you said it's being multiplied by m. And we need to do the inverse operation, so what's the inverse of multiplication? Division, so we're going to divide both sides by m. And m divided by m, anything divided by itself is 1, so we now have 1a. And I can't do anything else with f divided by m. I can't simplify that anymore. So I get that a equals f over m. We can flip that around and write a equals f over m. If we want the a on the left-hand side. So today we practiced these things. We determined whether an equation was true or false. Remember, if what's on one side equals what's on the other side, it's true. If what's on one side does not equal what's on the other side, then it's false. Sorry, that's my dog barking in the background. We also identified and applied properties of equality when solving one-step equations. If you guys have any other questions related to math and not about why my dog is howling, be sure to ask me in class tomorrow.